Robotik in der Industrie. Der Podcast mit Helmut Schmidt und Robert Weber. Hello everybody and welcome to a new episode of our robotics podcast. Today we are switching to English and embedding Texas Instruments into our podcast, so to speak. Thomas Schneider and Kristen Mogensen are my guests, and we will start by sorting out what their company does in the field of robotics. Enjoy listening. Thomas, welcome to the podcast.
Thank you, Robert.
And my second guest is Kristen. Welcome to the podcast.
Thank you, Robert.
We are sitting here at Texas Instruments in Freising, that's near Munich. Before we start talking about processing, communication, and perception when it comes to robotics, please introduce yourself briefly to the listeners. Thomas, please start.
Yeah, my name is Thomas, and I'm working for 20 years now for Texas Instruments. I started as a test engineer for microcontrollers. The nice thing with TI is that you have the possibility to change positions, so it was a little bit a longer journey to come to the robotics topic. I moved then to a system applications role where I supported customers in the field, and then moved to industrial systems, first focusing on factory automation.
So that's nearer to robotics, right?
Exactly, then going the way to robotics already with factory automation, continuing then with motor drive and equipment. And the last 6 or 7 years, I switched now into the robotics systems team, supporting customers with robotics development, how our portfolio fits for their development for mobile robots, industrial robots, humanoids, all kind of robots.
Kristen?
Yeah, my name is Kristen Mogensen. I've been working for TI since 2008. Mm-hmm. Here I started also as a journey to where I entered the robotics team similar to Thomas. But I started with broad market customer support, moving into motor drive, and then moving into the robotic space afterwards. Here I've been focusing for a long time on motor drives, communication interfaces, and now in the last 6 years I've been focusing a lot on functional safety, as this is one huge requirement for robots.
Huge, yes.
And you need to always discuss it and understand. So without this, it's very difficult to support customers in general in the field. And as Thomas is saying, what we try and do from a system perspective is to say, what are the different subsystems in the robot and how can you implement this with either existing TI parts or what parts are missing that we should try and develop for the future where we believe we could be successful.
Where do you see the biggest bottlenecks of development of robot systems in the moment?
So I think this question is a question where you need to split it up. Mm-hmm. I think first piece is you need to look at the different types of robots, right? What we see is there are mature markets.
So there's a new kid on the block, right?
Yes, exactly. So there is the humanoid new kid on the block. This robot here, it's a topic where I think everyone is looking at implementation. How do you make it work? I still think there are topics around it, like the functional safety topic is still a topic where
huge.
It's huge, and it's not. Everyone is working on how to actually do it, but there is no really. This is the way to go to implement it, and I think. And
you want to add something, Thomas?
Yeah, and regarding safety, also security, I think, which goes now hand in hand, is a big important topic with the Cyber Resilience Act coming very soon. And as the robots are connected more and more also to the internet and to the outside, I think there is no safety anymore without security.
But what about the traditional robot systems, Kristen?
So looking at the traditional robots, I think you can also split it here maybe in two sections. So there is the AMR type or battery-driven type robots. And then there are the stationary robots where you have a DC link connection through the power grid, right? I think if you look at the industrial robot, the big standard one like KUKA that you know is in the factory floor, and you see...
There are a lot more, right? Yeah. So ABB and Escava, we need to name them all.
Yes, exactly. So, but all of these, right? You see them, they have been in the market for a long time. They know how to build the robot. They build very good robots, all of them. And they know what is the system requirement and what is the need to make this robot work in this type of system. You have the cobot, it's still a little bit the new kid on the block.
Oh, yes.
And
the teenager on the block.
Teenager, let's put it teenager, right? Yeah. Here, the companies slowly also know how to build the robot. They are also slowly, many of them starting to say, they start building more and more component in-house. They don't take external components and build the robot with it, because now there is slowly a price pressure. And this is the same for the industrial robot. There is a price pressure. So a lot of it is they know what they need to build, but they're trying to simplify and cost optimize to build a more affordable robot. And this is the big topic in these type of robots. Then,
Thomas, you want to add something? Is that the most important topic when it comes to development, biggest bottleneck of development?
Yeah, for industrial robot, I think there is still a challenge for the pick and place, for example.
It's not solved yet?
I don't think so, that if you are in an unstructured environment and you don't know how your objects are there for pick and place, for object inspection and so on, I think that's...
We always see these fancy marketing videos, right? But there's also, every time there's a cut, because when it takes the item, and then there's a cut because in the next scene is then that has the part in the gripper. They do not film the ways how it really grips.
Yeah, exactly. And regarding time, how long it takes, I think there's still some room for improvement. For the cobots, I think the challenge still here is to make it more robust and generalize it. It's working together with humanoids, and you have to make them really safe. So that's, I think, still one challenge. In the cobot mode, it's moving quite slow, so it's not really efficient. Mm-hmm. That's a topic, I think, what needs to be improved regarding safety for the cobots. And then for the mobile robots, I think challenge here is still also the power consumption. And for all of them, the cost reduction, of course.
What is your offer when it comes to TI?
So TI actually is not building robots on their own.
You have no humanoid robot here?
No, okay. we are not building a complete robot. So TI is looking more into the subsystems of robots, and here TI offers a wide, broad portfolio of semiconductor devices, starting from analog parts like for the sensing, radar sensors, ADCs. For communication, we are offering PHYs, interface devices. On the processing side, we have low-cost small microcontrollers for the motor control, real-time microcontrollers, and then going up to the much more performant Jacinto processor family for AI, deep learning applications, object detection.
That's the next step, right? So humanoids, and now the whole AI topic comes also into play, right?
Yeah, exactly.
There's also the topic energy consumption, because what I see in the moment is that they build a robot, a traditional cobot, and they put a GPU next to the cobot. But this makes no sense from my point of view, or am I wrong?
Exactly. I think still it's not really optimized. Customers don't really know on their AI performance what they really need for the GPU, so they just put the most performant one into the system, that they are ready if they need a more performant model.
Kristen, you want to add?
Yeah, and I also think there is a second step into this discussion of the development environment, because a lot of time also there are limitations from the development organizations in the group where they're saying, I want to build an easy software, so I just take a high-performance CPU and I don't optimize the software. I just take the biggest and then I can do whatever I want. It's easy, but it's not, as Thomas is saying, it's not optimized yet. I think this piece is also a lot of times missing because you don't have the manpower to actually go do an optimized process anymore, and you need to figure out how do I split myself in optimizing and in what can I actually do with the people I have. And I think this is a very difficult task for a lot of robot companies to do this.
Is that a scaling topic right at the end, right?
Yes.
It's scaling. Or
There is exactly this scaling discussion of as soon as you sell more robots, you need to optimize it more. And this is something we see more and more with cobots, and we see it more and more in the industrial robots. This has already happened to a certain extent, right? And we see it also coming more and more into the AMR space, where customers build more and more of the robot in-house themselves to cost optimize, but also to say, well, maybe I don't need for this drive, I don't need super high precision. But for the other drive, I need super high precision. How do I do an optimized version for both where I don't put extra money on the table, which I don't need?
Exactly.
And this is some of the key discussion points and bottlenecks that needs to be seen over time for the coming future for all types of robot. And humanoid, they are early, but this also will come eventually, that you need to think of, is it really the optimum way, the most power efficient way, and the most cost efficient, or not cost efficient, but the most, let's say, did I get the most money out of the bucks that I put into the development, and how much does it bring me, right?
I want to come back to the scaling topic you mentioned. How do you support your customer when it comes to scaling?
So a lot of times we try and look at it system by system, right? So what we try and say is when a customer comes to us, we have a discussion of what are the points you built in-house electronically yourself, because then we talk on the right topics, because at the end of the day, if a customer doesn't build the PLC himself, it doesn't make sense to discuss PLC with him, of course.
Of course.
And then what we see a lot of time is the customer starts with the power supply. So they build the power supply themselves, and this is where we start helping them. So how do you do the power supply? What are the rails? What are some of the potential safety functions with voltage supervisors? Do you need a monitoring CPU that can potentially also need functional safety again?
Sure.
And I think functional safety is a topic we will come back to later with you. So we are not going to go in detail here, right? But more mentioning it's important. What you then see is the movement is going in okay, I built this system because I feel this is what I can do today. But I also want to do these and these other systems. And then the customer eventually say, oh, I want to build the drive now myself. Oh, or I want to try and build the camera, or I want to think about how do I do the communication interface myself, because I want to optimize my system. And we try and help them in this path, right? And
Thomas wants to add something.
Yeah, it's I think where we also help is with our huge portfolio to help the customer scale from single-axis motor control, for example, to integrate up to 6-axis motor control, for example, with one MCU, where in the past he used maybe 6 microcontrollers. Now he has just one microcontroller controlling 6 axis. Also on the safety integration in the past, for example, having a separate safety module, because safety might be optional in the past, whereas... Yeah, I mean for industrial robot, which is behind the fence.
Sure.
So there was not necessarily the need for the robot itself to be safe. But as now safety with the cobots is coming more and more and mandatory, so there we are also offering processors and microcontrollers with safety islands where you can integrate safety functions, that there is no need for a separate safety module anymore. So these kind of scalings for more integration, we also help the customers.
When it comes to perception, right? So what is your USP from TI when it comes to perception?
Depending on the sensing side, we are offering radar sensors, for example, which is an additional technology next to cameras to get more information and make it more safe, because you're using different technologies for the sensing, maybe for sensor fusion, those things. So we have a lot of sensors in our portfolio. On the processor side, we are offering processors, low power processors with integrated image signal processing functions, for example, integrated hardware accelerators for AI and deep learning, that you can really do your...
on-premise.
Yes,
that's important, I think.
That you really can do your AI models running on the processor, on the robot directly. with supported hardware like DSPs, matrix multiplication accelerators. And here we are also offering a lot of software tools like our Edge AI Studio, for example, that the customer can really bring his own model and compile it and run it on our process.
It's an Onyx format, or what is it?
This tool, or
no, the model. Is it an Onyx file, or is it a Docker, or what?
We are supporting different models.
So the standard of the model is Onyx, or what?
For example, yeah.
Okay. And I can then fine tune my model on your platform. Is that correct?
Yeah, exactly. So you can first of all test it.
Yep.
So with this tool, for example, we are offering EVM boards which are running in our headquarter, and you can kind of rent one for several hours. You put your model on this evaluation board.
Okay.
And test the performance on that processor, for example, that you don't have as a first step necessarily have to buy an EVM board. You can directly run it there, try it out, test it, and when your performance fits, then you can.
And then you download it and deploy it on the hardware.
Exactly, but the hardware in that case is in the headquarter. So in TI, but you log in via internet and download your model, test the performance, and after that, you can also use this model then to convert your models, or you train your own model, of course.
I want to come back to this GPU next to the cobot discussion. How big is the topic AI from a customer perspective, from your robot customers? Are they willing to do something in the field, or are they waiting for new models? Or
for the perception and sensing, I think a big topic here is still safety. What is not?
This is a little bit difficult when it comes to AI. Right?
Exactly, but there is things ongoing that they work on a new safety standard for AI, how to use AI models in safety applications.
How to bridge the gap between both worlds? Because I think from my point of view, it's still two worlds, right?
Yeah, exactly. At the moment, you have still your AI, which is kind of
deterministic,
a black box, and then you have your safety around it, your safety functions, which monitors and watch that this AI is not doing something wrong.
Yeah. But what is the idea to bridge the gap between both worlds?
The idea is that you can also use in the future AI-trained models for safety applications. So not necessarily just safety applications which are written in C code or hand code, deterministic, exactly. But also using AI models in the future for safety functions.
Okay, but this is a way to go. Is it 2 years, 5 years, 10 years? What is your...
I think still several years, definitely. I mean, it depends how fast they can complete this safety standard. So there are a lot of big companies involved and pushing for it.
What is the benefit when it comes to AI and safety, to combine both worlds? What could be one benefit out of it? Because a lot of people are asking this question, because safety is solved, right? It's deterministic. And why do we need now an AI add-on?
For additional safety functions, I think for in the original ISO 10218, I think there were only 2 safety functions defined, safe stop, and in the new version you have now a lot more safety functions, and for that additional safety functions like safe limited speed and so on, but also for a humanoid robot, I think that's an important thing to use perception, because you cannot just trigger safe torque off and stop the motor. So you need to do a little bit more here on your safety functions, and then you need the information from your perception and in what state the humanoid robot is.
I want to come back to the topic Edge and AI. What is your offer when it comes to Edge AI or embedded AI?
So as mentioned, we have this Edge AI Studio toolkit for our higher performant processors, but since some time now This tool also supports our lower power MCUs, real-time MCUs for motor control, for example. Maybe Kristen can give some more details here.
Yes, Thomas. So what we also have with the motor control, we have examples, for instance, showing if the bearing of the motor goes broke, you can measure it, and then you can use...
It's a time series topic, right?
Yes, exactly. So you can actually use the measurements for the motor and then detect if the bearing is broke and show it that this motor is breaking, I need to replace it eventually. This is a demo we already have available, but there are many different options of using this, right? Using temperature measurement, pressure, whatever you want, but it's already in the smaller processors, and you can, let's say, the sky's the limit, let's put it this way.
Let's talk a little bit about processing and communications too, because the topics are connected, right? So how does the system connect different subsystems of the robot? So we talk about cameras, we talk about new controllers and stuff like that. We have a lot more add-ons at the end. What do you offer there, and what are the customer needs there?
So I think here what the customer need is very diverse here.
Okay.
First of all, but what we see is that you need to kind of think on it on a holistic approach, saying, I have my motor drive, or if you go to the smaller piece of it, you have your torque sensor, you have your encoder. How do I connect these two to my motor drive? Then how do I connect the motor drive to my motion controller? Then you have the motion controller. Where does the motion controller get his information that he decides to do his motion? So you have the perception, and you have different control loop for different levels. So you need the data quicker and quicker and quicker and quicker.
Yeah,
depending
and also
how far down you go.
From the components, right? Yeah.
Exactly.
Yeah.
And this is exactly the big question. How do I get the data fast enough for the individual function, real time, and how much data is this? Mm-hmm. Because then, for instance, you add functional safety on top. You have the definition in industrial world called black channel. We'll go in discussion of that, what that is later, right? But the black channel at the end of the day mean more data. Mm-hmm. So this black channel approach basically increases the bandwidth requirement. So suddenly some of the traditional ways of doing it potentially is not fast enough anymore. How do you deal with this? Mm-hmm. Then you have the second point on top is you still have a battery-driven system. Mm-hmm. What's the answer on this? And this is where it's an evolving process where I don't think there is one way to go. There are several
What
options.
is the TI way?
The TI way is actually, we have RS-5 transceivers, we have CAN transceivers, we have standard Ethernet, we have single twisted pair Ethernet, we have FPD link. Mm-hmm. So we kind of have all different topologies, and what we are trying to work with customers is saying, when we understand and help you with your system, we try and help him saying, these are the options, these are the comparisons, and we compare the technology, and then we try and help him which one fits your system at this section best, mm-hmm. and how do you then put this to the processor. And this is how we try and help the customer.
So you work very close together with them.
Exactly. What we see as a trend definitely is there is a trend that single twisted pair Ethernet from automotive is coming up.
Can you define a little bit what is the difference?
So the difference is single twisted pair is you have Ethernet communication, but only on a twisted pair instead of either 2 twisted pair or 8 twisted pairs. Now, one piece of single twisted pair that comes into mind is EMC, EMI. Mm-hmm. What we have seen with the measurements we have done is, yes, automotive PHYs can be used for industrial environments, but not in the way the automotive industry implemented the standard. So you need to do something different. What we have shown here is with measurement is that if you change the termination different, you can easily pass all standards. Mm-hmm. But if you keep the capacitive couple standard, you need to shield the system from noise. Otherwise, you will lose the link, which of course in an industrial system is, if the link is gone, the system doesn't work, it's not a good thing, right? You don't want that. And what we have also seen, and this is a second piece of the humanoid that differs from a factory floor, is the distance you need to send the data. Mm-hmm. It's very, very short compared to what you would need in other systems.
Exactly.
And this also, let's say, opens up for new technologies or potential old technologies who have a revival simply because you don't care about the distance anymore. But with a short distance, you can actually go higher speed, right?
Okay.
And this is where we are trying to work with customers, figuring out what's the best option. Because, for instance, if you have a very small, compact system, you can't put 4 PHYs in a small system. It's simply just not possible because you have a size limitation. And this is also, there is the size limitation, there is the power requirement, there is what is the actual amount of data, how fast do you need to pass it. These things come to combine, and this is why we are saying we are comparing technologies. We are not saying this is the one way to go. One thing that's nice with automotive Ethernet, to put it back on this, where we say it has a lot of potential, is also the capability that you can diagnose the connection, so connector to connector or PHY to PHY through the connections, and you can do this non-intrusive. So you are able to diagnose what's the signal quality while you're communicating. So you can say, if my system is breaking, I'll detect it before it breaks.
Okay.
And this is a super nice feature of the technology.
Yeah. So you mentioned automotive. You both worked in industrial systems. Let's compare a little bit the world, the robotics field, the industrial systems world, the automotive world. Which branch is in the lead from a technology perspective? Because you said, I will take something out of the automotive industry. You said we can take something on the industrial systems. So when it comes to perception, communication, who's in the lead?
In the lead, I mean, automotive has much higher volumes.
Yeah, sure.
And I think robotics is taking this, and it's a big advantage that the devices are already available in high volumes from automotive.
But when it comes to new protocols, because there's a different architecture when it comes to robotics, or am I wrong?
It depends on which robot. If it's a mobile robot, then you carry a mobile robot with an electric car, so the architecture might not be that different. Of course, the old industrial heavy load robots, they have a complete different architecture. On the safety needs, of course, there is this difference that for automotive, you can do your testing during startup, and then you know after a few hours latest, the car will be stopped, and you can do your diagnostics again when the car starts the next time, whereas the industrial robot applications, they typically run 24 hours, 7 days. So
they should.
Yeah, and here you have to do your diagnostics during runtime. So that's one of the differences here on the safety topic. In robotics, you might have still your defined environment for cars. You're driving outside and it's not defined. So that's another difference.
You deliver products in the industrial systems and automation and let's call it traditional automation fields. What is so special when it comes to robotics? How different are the customers there? Do they have different needs when it comes to communication, perception, topics like that?
In general, it's a little bit difficult generalizing it, because in some topics, you would say they need the needs from an industrial plant, and in other topics, they would probably want to go more in the direction automotive. Because some of the systems, I think perception, is a good topic to grasp on here. Because with perception, right, with all the autonomous cars and the data you have with the cars, you have a lot of data to work from, right? This information is not available from an industrial floor yet. It will be eventually, but right now you have more data and more experience from automotive. So here, the merge is a, let's say, a good point. Then, if you go for the motor drive perspective, right, here you need very deterministic, very real time, to a certain extent, high precision drives. Here, the need is more from an industrial perspective, because you need to sync all the motors, which is in a car not potentially as necessary. And this is where it's kind of, I think you will see there is a pick and place where some systems, the automotive world makes more sense, but you still need to now convert the automotive world into an industrial safety environment. And this is a big step, and it is a difference.
Is it also for you a big step to do that?
It's a big step for the customers to do, and it's a
for you it's very easy.
we only work with the industrial mindset. So
Yeah.
for us, the mindset is normal. But if you come from automotive and you go to industrial, the mindset is completely different. Also from the assessors, and you need to learn this. And this is a big step.
Thomas?
Yeah, I mean, for us, it's for the devices at least, it's quite easy because they are typically safety certified for ISO 26262 and IC 61508. So they are certified for industrial and automotive. So that's not such a big problem where then the devices is used. It's just to pick the right one for the right application.
Let's talk a little bit about the last exciting project you did together with a robot company. What comes in your mind?
Yeah, one example I have is, I think that's also public on the internet, is we work together with Amazon on developing new mobile robot platform, Proteus, which they use in their warehouses to transport the packets. And that was really an exciting project.
What was so special there?
They developed this mobile robot exactly for their needs and for their warehouse needs. And they have a lot of cameras and sensors around, so it was quite a complex mobile robot.
And what about you, Kristen?
So I think for me, I cannot mention a specific customer.
Yeah, sure.
But what I say is that a lot of basically discussion around motor control, functional safety, and how to make that a system which is optimized for robots. And then the discussion around the communication architecture inside the robots. I think those are the two most exciting topics that I'm working on right now, where you see you are moving the technology to the next level, which is very exciting. And you see
what is the next level? What can we expect?
So I think, and this is the big thing we discussed a couple of times, is the functional safety requirement. Right now, the first level is I make a functioning robot. And I think this is where you see they are fine-tuning the processes. They are working on what are the missing links where it's not quite there yet. I think one big problem customers are looking at a lot today is how do I make the hand quicker and better to get things. And this is basically a limiting factor of the uses of the robot today. But a second step is also how do I make it safe? And this is a quantum leap with the robot, because making a functioning robot and making a functionally safe robot is now is as you say, it's two worlds, function and safety, but you need to combine it now. And this is a very big step that customers are starting to develop and do now. But and also what we see, there is actually a safety standard being developed for humanoid robots, right? And this is still in the draft, so there's still some years to come. But eventually, it will be finished. In my anticipation, I would say the standard will be finished in 5 years. So in 5 years' time, all humanoid customers need to have a strategy. How do I, from now till five or let's say 7 years, how do I have a safe system from now till at that point? And what is that safety requirement? Because the problem is it's a draft. It can change.
Absolutely.
which is a very big, troublesome task for customers at the moment. And I think this is the most exciting, this how do we make them safe that you can actually start putting them out in the world? And what does that safety mean? Which is also where we are trying from TI to also be part of the robot standard committees to try and make let's say a safer world with the robots and having let's say paving the way for the future, so to say.
Thomas, what is in your agenda in the next coming months?
On the agenda at the moment, I think is a sensor fusion project for perception. So where we are working to combine our millimeter wave radar sensors with camera, plus our Jacinto processor family, so that the processing can be done at the edge on the processor itself, not in the cloud.
That's crucial, right?
Yeah, exactly.
Yeah.
Also for the latency and for the timing, for the security, for privacy. Here also our radar sensor has this advantage that you don't see the person itself. So sometimes when people see a camera, they might be a little bit scared or that they are watched. So that's one project, how to use the millimeter wave radar for perception.
Okay. What is your agenda, Kristen, for the next coming months?
So for the next coming months, for me, it's working on how to build an optimized motor drive with functional safety feature on an architecture level. This is where we are working with TÜV to achieve this and have a TÜV certification on it, and this is very exciting.
So you both guys came from the industrial systems topic, right? So is there any moment you say, I want to go back to the industrial systems, or do you say, I want to stay with robotics the next 10 years because it's so fascinating?
Well, in the robotics, at the end, you have kind of all end equipments from the industrial systems. You have the sensors, you have the kind of PLCs, you have the motor control. So I think it's a really fascinating topic to work on. And
you don't want to go back?
No, when you look what's coming in the future, I think that will be really exciting.
Yeah, I can only say the same. I find it's a super interesting topic, and it's very motivating to work on. And in general, as Thomas said, the thing with the robot is you have every system inside, so you can choose where you want to work next. And as we see with TI, we have components that fits all subsystems. So you have a very wide option of end equipment you can dive into and learn in detail. So it's very exciting, and I think there's a lot of new systems that needs to be developed to make these new end equipments successful, so to say, and it's exciting to work with.
And is there a different spirit in the field of robotics compared to the, let's call it, traditional automation companies?
I think it depends on which company you're working with.
Okay.
I mean, there are the traditional industrial
in quotation
robots,
marks, yeah.
Customers working on these heavy load robots. They are kind of the same, I think. But then you have the startups and the new companies on the mobile robot, and especially also on the humanoid.
Do you need to ground them sometimes, the startups? Because they have great ideas, and then they're coming to you and say, yeah, but we need to do this perception. We have to talk about safety. We have to
exactly.
talk about communication. We need to ground you guys.
Very often it's just that it's about the functioning and doing fancy stuff, but not really thinking already from the beginning about the safety topic, for example. If you start too late here, then it's very difficult to, at the end, certify the robots. So.
Yeah, and I think one example I think is we've seen in some cobot companies where also very nice, super nice solution, and then you need the safety certification to make it work, and this can take up to 3 years if you haven't thought of safety when you started to architect the function. And you need to have this switch and eventually in your prototype where you say, the function, we can do it, but now I need to put safety on top, and you need to make that decision early. The earlier you do it, the easier it is to implement. The later you do it, the longer typically it takes. And eventually we see some customers say, well, I can't safety certify this. I need to do a new system. And you don't want to do that.
At the end, one question concerning ROS. What is your opinion on ROS 2? Is it more a scientific playground, or is it really becoming standard when it comes to AMRs, or maybe also to industrial robots?
Yeah, ROS, definitely an interesting topic. So we also support ROS on our processors. We have a specific robotics SDK where ROS is running for your development, for example. Also, our millimeter wave radar sensors have drivers to support ROS, that you can test the radar sensors in the ROS environment.
So you already mentioned test environment, so it's more a test environment topic.
Yeah, in my opinion, yes, because for real-time applications, it might still necessarily not be the best option. But for development, putting something quick together, testing sensors, doing some measurements, I think that's a great tool.
Thank you, guys. It was a pleasure. Thank you, Thomas. All the best. Keep fingers crossed for your sensor fusion topic. And Christian, thanks a lot. Keep fingers crossed for your approach with the TÜV.
Thank you, Robert.
Thank you, Robert.
Robotik in der Industrie. der Podcast mit Helmut Schmidt und Robert Weber.